All right. Thank you, everyone, for coming today. I was a little worried that people were going to show up for a 7 p.m. session, like too busy with dinner and happy hour, but I'm glad there was some turnout here. My name is Kai Zhao. I'm a principal product manager for DynamoDB, and today I'm going to be talking to you about how to scale fearlessly with DynamoDB and about adaptive capacity technologies. So the agenda for today is that by the end of this, hopefully everyone in the audience should be becoming an Amazon DynamoDB scaling expert to know how and when DynamoDB scales. I'm going to talk to you about some new tools and features and help you prepare for unpredictable traffic, for that unpredictable product launch when you don't know how much to provision. And lastly, we're going to be going over ways to save money, to really optimize your bill and be more efficient about how you use DynamoDB and just achieve a reduction in your monthly AWS bill. So customers come to me all the time with these sort of common scaling scenarios, right? And probably the most common is that it's 3 months out and I've got a product launch, right? Or I'm launching a new website, or I'm launching a new web service, and I don't really know how much traffic I'm going to get. But I do know one thing, which is that I don't want my customers to be browned out on day one, right? And so they often come to me and ask, well, how should I provision for DynamoDB? What should I do? I could provision for millions and millions of IOPS or millions of requests per second, but that's also going to be quite expensive, right? So how do I do this in a cost-effective, efficient way? Another really common scenario is if you're a cat owner like me, you'll kind of notice that your cats are a little more active in the mornings and the evenings, right? It's like this sort of diurnal pattern. A lot of customer applications actually behave very similarly. For example, if you are in the transit or transportation sector, some of your applications you find may be more active during morning rush hour and evening rush hour, right? And a lot of customers have similar patterns where they're just predictable, spiky, but predictable traffic patterns. And of course, the third scenario is I'm building something. It might be an internal service, and I just really don't know what the load is going to be. I have no way of forecasting how many people, how many applications are going to use my service, and therefore I just need to I figure I need to input something into DynamoDB, right, to tell DynamoDB how much throughput I'm going to need. So what do I mean by scaling fearlessly in this session? Well, this is a great example of this. This is a real customers table. This is a customer in the financial services industry. They're a fairly prominent company. And they were able to scale up their workload from 900 writes per second to 25,000 writes per second, a 25x increase, really just in a matter of seconds. And what's interesting to note here is that they had zero operational management of this table, right? There was no one going in and adjusting knobs to configure WCUs or RCUs. They just opened the floodgates and let the traffic in. And by the end of the session, I hope all of you will be able to have the confidence and understanding to do something similar for yourselves and for your own applications when your companies get really popular. So some key takeaways from this session. First, I'm hoping to impart the idea that DynamoDB accommodates your workload, not vice versa. Our intent is not to make any of our customers learn the nuances of how DynamoDB works. Rather, we're just going to accommodate your workload, even if it's imbalanced, even if it's unusual. The second is that partitions don't actually matter anymore. Individual keys do. I'll get more into what that means. And the last thing is that you should switch capacity modes. You should take advantage of DynamoDB's support for various capacity modes to optimize cost and performance. So let's start by talking about the DynamoDB approach to scaling. And I think it's helpful. It's not really meant to be a history lesson this session, but it is worth noting, kind of remembering why DynamoDB and why NoSQL databases exist in general, right? Database capacity planning has always been this thankless but critical task, right? You're always trying to straddle or walk this tightrope between provisioning too much capacity, the white line, relative to usage, where that's essentially just wasted capacity, or provisioning too little, where now you have dissatisfaction because you have customers who are unable to access your service, your website, you're losing revenue maybe, and your leaders are upset. It's one of those jobs that if it's done correctly, no one really notices, but if it's done poorly, everyone's going to notice. And so traditional database scaling or vertical scaling really is a pretty simple concept, right? You just essentially buy a bigger box. You buy a server with more CPU, more RAM, more disk, and this is just going to accommodate your growing workload. But there's some major downsides to this, right? First and foremost, there's often downtime when you upgrade, when you migrate your application from one set of servers to the next. You're perpetually going to be underutilized because you're always going to have a more powerful box than you need up until the moment where that threshold crosses over. And at some point, as your business continues to grow, you're going to reach a point where there just doesn't exist a more powerful machine that's going to be capable of serving millions and millions of requests per second. So back in 2007, this is why DynamoDB published the Dynamo paper, right? And this is a paper that came about because Amazon.com, the retail company, realized that a lot of its relational databases were really just being used for key value lookups. We weren't taking advantage of all of the joins and other capabilities that relational databases offered. So we published this paper, and this paper kind of became the building block for not only DynamoDB, but several commercial offerings of NoSQL databases. And so with the advent of the Dynamo paper and these other NoSQL offerings, we now come to this notion of horizontal scaling, right? Where rather than buying one very powerful piece of machinery, you essentially buy increments of essentially smaller, more commodity-grade hardware. So this lets you scale up in more precise, fine-grained increments, which lets you be more cost-effective and also lets you scale down. But even so, there's still some downsides to doing so, right? You're now managing a cluster or a fleet of these instances or hosts. You have to do OS patching. You have to upgrade the database software. You have to do operational maintenance. You have to do on-calls in case your fleet goes down or your certain clusters go out of service. So there's still a lot of operational overhead to doing this. And across NoSQL databases, there's this common problem of uneven access, right? And what do I mean by uneven access? It kind of takes two flavors, right? One is uneven access across data, right? So think, for example, here where, take your favorite like movie star, singer, social media celebrity, their social media pages are going to get way more hits than my social media pages, right? So you just have a certain measure of imbalanced traffic based on the data that people access in your database. And the second is imbalance across time. So imagine your company runs an ad during the Super Bowl, right? During the commercial, immediately afterwards, you're going to get a lot of traffic directly to your website, and you better hope your database can keep up. So how do you address this problem of uneven access that's really common to almost all NoSQL databases? Well, if you dig down deep into the documentation for almost every NoSQL database out there, you're going to come across a page, and it's going to be called Best Practices for Schema Design, or Best Practices for Primary Key Selection. And this page is going to say something to the effect of, whenever possible, design your workload for uniform access, both across data and across time. The problem, though, is that this can be quite difficult in practice. And most NoSQL databases are not very forgiving, right? For some NoSQL databases, for example, if you have an imbalance in data, you have no choice but to essentially just refactor your application and essentially do a bunch of resharding on your database, which is no fun. And if your database isn't flexible, you essentially have to handle more in your application. And of course, who wants to do that? So how does DynamoDB solve this problem of imbalanced access or non-uniform access for our customers? This is where adaptive capacity comes in. So just to clarify, adaptive capacity is not one single feature. Adaptive capacity is DynamoDB's umbrella term for a number of technologies. And the goal of all of these technologies is to enable DynamoDB customers to essentially have to minimize the amount of time they have to spend thinking about how their workload is structured and about how their key schema is structured. The idea is that we just accommodate your workload, however it may come to us. And there's three core functions of this adaptive capacity technology: dynamic partitioning, high traffic item isolation, and throughput boosting. And we'll start talking about what these are. So let's talk about dynamic partitioning. So, ever since DynamoDB launched, or rather, sorry, let me just go take a step back here. Behind the scenes, the way DynamoDB works is that we essentially will take your data and we will shard it across several partitions. And these partitions are located on physical servers, physical hosts that constitute our storage node fleet. So in this example, right, you can see that table 1 has a partition on server 1, it has a partition on server n, and this is repeated for basically every DynamoDB table in existence, right? They're distributed across these servers, across partitions in random ways. And in terms of storage scaling, we've done this actually since the start, right? So for example, if you have a table that exists on one partition, and that partition starts getting full because you're doing a lot of inserts into that table, we will actually split that partition for you automatically, no input required, and we'll split it across now these two partitions across these two servers. And this is a multi-generational process, right? If B gets full, we split B, now you have B and C. If A gets full again, we can split A again. And now you have essentially 4 partitions distributed across 4 servers with no input required from you. This is just basically you loading more and more data into the DynamoDB system. So let's take a hypothetical example. If you've read the original DynamoDB blog post about adaptive capacity, you may be familiar with this sort of Canadian census demo. And the sort of hypothetical scenario is that the Canadian government hires you to build an online census application. And you choose DynamoDB, and you choose the following key schema. The partition key is going to be the province, and the sort key is just going to be a random request ID. So what you didn't realize, however, is that Canada's population is not at all equally distributed, right? Ontario and Quebec have 2/3 of Canada's population. And in fact, my Canadian coworker pointed this out to me, that 50% of Canadians actually live south of that line. So if you chose province as your partition key and request ID as a sort key, you've immediately got yourself off on the wrong foot, right? Because you've kind of built yourself into a really imbalanced workload. So let's go to the demo. All right, so what I've got loaded up here is the census demo with some changes to it. You can actually download this demo yourself. If you just Google DynamoDB adaptive capacity, go to the blog post, there's a link to a GitHub repository, and you can download this yourself. But I've made a couple changes to this in the interest of showcasing some of the features of adaptive capacity. So first off, I'm not going to go through all of the code, but just a couple things to point out here is that when I'm creating this new table, I'm going to create it using paper request mode. And this is essentially the mode that means on-demand mode rather than provisioning. So I don't have to provision any WCUs or RCUs. The intent here is just to focus on the consumption rather than any kind of provisioning levels. And the second thing that I've changed from the GitHub version is I've added basically an exponential growth function. So what this is going to do is the application is going to drive basically synthetic traffic, as if citizens were putting in their census information into this app, and it's going to be distributed based on the real life distribution of Canada's population across different provinces. So let's kick this off. Oh, the font? Yeah, sure. Let's see here. Is that better? Yeah. All right. So we're going to start the demo here, and I'm not going to this actually takes about 3 hours to run, so I'm not going to do the whole thing. But the important thing to take away here is that you can see here that Ontario and Quebec are driving a lot more traffic than the other provinces. And this is going to emit basically a record once every 10 seconds. And it's being driven to this table here in DynamoDB called Census Demo reInvent 2019. And you can see the items that are being loaded are basically just some simple records of a province ID and a response ID. So going back to the presentation for a sec. So what's actually going on in this demo, right? I mentioned that the synthetic traffic is being driven in real-life proportion to the Canada's population. And just through random chance, it turns out that DynamoDB's hash function happened to place the strings for Ontario and Quebec on the same partition. Recall that DynamoDB essentially uses a hash function to take in partition key values and assign them to DynamoDB's hash map, which is basically where the data in your table gets routed to. So, by chance, the two most populated provinces are on the same partition, and British Columbia and Alberta, which are the two next most populated provinces, are now located on the second partition on server 2. So combined, these two partitions are driving 92% of this workload's traffic. So you might expect that for such an imbalanced workload, that DynamoDB is going to lead to a lot of throttling. In fact, what actually happens is, after about 3 hours of running this workload, you can see a pretty smooth upward ramp. There is actually no throttling, and that's because of adaptive capacity. Talk a little bit more about that. And you may be wondering, well, this is an example where Kai drove a sort of gradual curve. What if I were to just slam DynamoDB with all the requests all at once with no growth function? You would see something like this. In this case, I just drove about 4,000 requests per second. And you can see these sort of stepwise functions here in the graph. These essentially represent DynamoDB doing partition splits behind the scenes. And every time we do a split, we're essentially doubling your capacity. And in this case, I just stopped at 4,000. But going back to this slide here with the smooth curve, what's actually happening behind the scenes here is that we have these two partitions that hold Ontario, Quebec, and British Columbia and Alberta are getting a lot of traffic. DynamoDB is doing a partition to divide Ontario onto its own partition and the other less populated provinces onto a different partition. In addition, because Ontario is so populated, it's got so many synthetic traffic requests going to it, that we will actually subdivide Ontario again into Ontario A and B. And British Columbia and Alberta also being highly populated, we're going to move British Columbia and Alberta onto separate partitions. So there's two interesting things to note here. First is that frequently accessed keys will eventually be isolated onto its own partition, like in the case of British Columbia. And the capability will even divide individual sort keys in the case of Ontario. DynamoDB will find a logical split point and divide the partition key. Now, this sort of thing would not happen in an ordinary NoSQL database. You would just be stuck with this imbalance, and your workload wouldn't scale properly until you either refactored your application or redesigned your key schema and just did a lot of work, right? So again, that's key takeaway number one, which is that DynamoDB, we intend to adapt to your workload, not vice versa. Even if your workload is imbalanced, we have a number of technologies in place that will just accommodate your imbalance without forcing you to do unusual or unnatural things. So let's talk a little about high traffic item isolation. And this is actually very new. We just announced this about 2 weeks ago. And you kind of saw a little bit of that at play in the previous demo, but this is a more general explanation of how this works. So let's say you have a partition, and two items on this partition, we'll call them item foo and item bar, are just driving a lot of traffic, right? And these two items combined are basically hogging all the throughput capability of this partition, and the other items are getting short shrift. So what DynamoDB will do is it will detect that this sort of imbalance is happening, and we will split partition A, and we will split it into A and B in such a way that ensures that items foo and bar now live on separate partitions. So in this case, item bar is now a little happier, right? It's now not competing anymore with item foo, and it's using a smaller percentage of partition B's overall traffic than it was before. However, item A is still really just driving a crazy amount of traffic, and it's still consuming all the throughput capabilities that partition A can provide. What DynamoDB will now do is we will isolate item foo onto its own partition, partition C. And for any other database, you sort of think about or manage heat at the page level or the node level or the host level, because several hot rows can be co-located on the same page, node, host, what have you. what DynamoDB has done is we've redefined the notion of a hotspot down to the item itself, right? We isolate, our split technology isolates this hot data until the unit of heat becomes the item itself. And at that point, the line between what a partition is and what an item is becomes very blurred, right? Because, yeah, there are partition limits, but if there's only one item on the partition, the item limits and the partition limits essentially become one and the same. So this is key takeaway number 2, which is that partitions don't matter anymore. Individual items do. So what does this mean for how you approach design on DynamoDB? From talking to customers, especially customers who haven't been keeping super close tabs on the DynamoDB Twitter account or the DynamoDB, the database blog, there's, I think, a residual perception that partitions are really important, right? I've got to make sure that I don't have too many partitions because my throughput's going to be split, or they want to know, like, well, when is my partition going to split, or can I see my traffic across partitions to see which partitions are busier than others? And my response to all these customers is, you don't have to worry about this stuff anymore. Essentially, partitions and keys, we've essentially blurred the distinction between the two. And really, the only thing that you should be aware of now, or pay attention to, is what your key level traffic is doing, right? So a good example of this is, the maximum throughput capable on a single item or a single key is 1,000 write request units or 3,000 read request units. That's strong consistency. If you were to do reads, it would be 6,000 at eventual consistency. Now, that's really the only thing you have to pay attention to now. It doesn't matter which partitions those items are located on, because we're essentially going to be always moving those data across partitions anyway. You just have to pay attention to what individual keys are doing. And for example, if you have a really high read workload that exceeds 3,000 or 6,000, well, I mean, that's a good case to use DynamoDB Accelerator or DAX, which is DynamoDB's built-in caching, right? It'll let you scale your read workload up way higher than 3,000, 6,000. Or if you have a write workload that's exceeding 1,000 writes per second, I strongly encourage you to go watch Rick Houlihan's session, Advanced Design Patterns for DynamoDB. It's on YouTube. He's also doing repeats of it at reInvent this year. And it's one of the most valuable ways to learn how to be more efficient on DynamoDB and really design your workloads and your schemas in such a way that takes advantage of the NoSQL technology rather than being bound to some of the more traditional relational database tenets of how to structure your data. So some common questions that I get is, okay, you just told me that partitions don't matter and only items matter. Well, how do I see traffic at a per item level? And up until last Tuesday, you couldn't, right? Unless you were to build, custom monitoring yourself to measure individual keys. So last Monday, Cloudwatch released Cloudwatch Contributor Insights, which, in and of itself, it's a pretty cool tool. Cloudwatch Contributor Insights, excluding DynamoDB, you can think of it as top talkers, right? You feed in Cloudwatch logs from, for example, your own application. And you tell Cloudwatch, I want to identify, top talkers on these, X, Y, and Z dimensions. Maybe, like error rates or, like most utilized instances or something like that. And Cloudwatch Contributor Insights will identify those top talkers and produce graphs for you, showing you, which ones are actually those top talkers. The day after, DynamoDB announced Cloudwatch Insights for DynamoDB, which is a one-click integration between DynamoDB and Cloudwatch. And what this provides is key-level activity graphs. It lets you identify frequently accessed keys and traffic trends at a glance, and lets you respond appropriately to unsuccessful requests. So let's go to a demo. Is that showing up properly? Great. All right, so I'm going to my tables. I've got Contributor Insights demo. This is a table. And I've had a workload running on this, basically since last Friday. And you can see here that what we've added is this new line here. I can't highlight that properly. There we go. Cloudwatch Contributor Insights. Contributor Insights is still in beta. But we expect to be out of beta very soon. And you can click this button. It takes you to a management screen. I've already got it enabled, so I'm not going to do anything here. But the takeaway here is that this is basically just a binary on or off. You turn the feature on for a table or a global secondary index. You turn it off. So now let's go and see what these graphs actually reveal to us. So this is a graph of data about this base table. And you can see here, let me just actually update the time window to be a good time window. 29th to the 30th. All right, so what are we looking at here? On the top, you see these two graphs called most accessed items. One is partition key only, and one is partition key plus sort key. And so these graphs, as the name suggests, they tell you which of your items, which of your primary keys are most active. And you can actually hover over these graphs. For example, the most accessed item key. You can see here that at this moment in time, New York was your second most active key. This can be, for example, take your pick of hypotheticals, but imagine this represents, for example, Amazon.com retail shipments, right? So in this moment, there was New York was number 2 at 262K. 262K what's, right? The y-axis here is something called consumed throughput units. This is a new metric in DynamoDB. And what this metric shows is it's essentially the sum of reads and writes with some weighting implied. So effectively, it's 3 times reads plus writes. And what this metric shows is it's a single way to look at all total traffic, read and write traffic, to identify which keys are accessed most often. And on the right-hand side, you can see that we actually do this both at the partition key level and at the sort key level to provide more granularity. So you can see that at the partition and sort key level, there's really only one item that's very hot, and that is this item here called Sydney Test GUID. And this is an example of how you can actually use this tool to diagnose problems even before they become problems, right? So in this case, this is a good representation of a common problem that you might have is you might have a canary that you forgot to turn off, and it's driving a disproportionate amount of traffic. It's test GUID, right? You can actually use this tool to identify not only your most throttled keys, but also your keys that have skewed traffic even before they become throttling problems. And on the bottom here, you have these two graphs called most throttled items, partition key only, and partition plus sort key. So again, it's the same concept. We provide them 2 slices of data, partition and partition plus sort. And you can actually see what's happening here is this is adaptive capacity at work, right? You can see that the throttling is effectively going to 0 because adaptive capacity is kicking in, and it's handling this really imbalanced workload. So some of the other features to call out here are that you can also view this data in Cloudwatch. So if you click View Rule, behind the scenes, when you activate this feature, what DynamoDB is doing is it's creating what are called Cloudwatch Contributor Insights rules. And these rules scan Cloudwatch data, or rather DynamoDB data, to identify the key activity. And so if you want to get more sophisticated, you can actually get out of the DynamoDB console, which is mainly a view-only mode, and you can actually go into the Cloudwatch console. And this lets you essentially take advantage of all the different Cloudwatch functionality, right? You can change, for example, if you want to see more than top 10, you can see top 20, right? You can see data over a 1-minute period, a 1-hour period, a 1-day period. And in addition, you can add this data, for example, to dashboards. So if you have dashboards, you can add them to dashboards as you normally do. You can create alarms on your DynamoDB Contributor Insights graphs. It gives you the full power of the Cloudwatch toolset in order to use this data. So let's go back then to the presentation. So pricing for Contributor Insights is $3 cents, not $3, 3 cents per million events. And events are pretty unusual. This is a new concept in DynamoDB, and it's really regardless of item size. So if you're doing a 400 kilobyte write or a 100 kilobyte write, it's still only one event in either case. So item size doesn't matter. Whether it's a read or a write doesn't matter. And whether it's provisioned versus on demand also doesn't matter. An event really just represents an item that's being accessed in DynamoDB. So if you're doing a write of a single item put or a single item get, they both represent one write. If you're doing, for example, a batch update, a batch write item that inserts, let's say, 10 items, you get metered for 10 events. And it's pay as you go. You can activate it or disable it as needed. So, for example, if you don't actually need this capability around the clock, but for example, you have a large product launch that's coming up, you can just turn this feature on, essentially watch it for the duration of your product launch, and then once traffic has died down, you can just turn it off and we'll immediately stop billing you for it. So I've already talked about you get customizable granularity and time windows, you get Cloudwatch alarms and dashboard support. Also, if you want to retrieve this data programmatically, Cloudwatch offers a Get Insight Rule Report API, which allows you to essentially get the contents of those graphs programmatically instead of via the console. Another common question that I end up with is, well, what if I end up with too many partitions, right? And the common sort of misconception here is that, let's say I've got a workload that's got 1,000 writes per second on it, and I've got one partition, and then I dial that up to 100,000 writes per second. And now I've got 1,000 partitions to accommodate this increased traffic. If I'll dial back down to 1,000, well, won't I have now some dilution because my 1,000 WCUs is being distributed across 1,000 partitions? And the answer is, partition count doesn't matter anymore because of instantaneous adaptive capacity boosting. So let's briefly review what adaptive capacity boosting does. So if you have a workload that's being driven to, for example, 4 partitions, and let's say that partition A is getting the bulk of the traffic. So partition A is now fully occupied in terms of throughput. What DynamoDB will do is we will check, is this table as a whole at or below its provisioned throughput? If it is, then we're simply just going to boost the amount of throughput that partition A gets. It's as simple as that. And what's new in this year, just a couple months ago, is that we made this process instantaneous. So partitions respond instantly in response to changing traffic. So what does this mean for you? Well, DynamoDB instantly accommodates imbalanced traffic, and we do so indefinitely. It's not a temporary thing, right? You may be familiar with concepts like DynamoDB's 5-minute burst capability, where you essentially can stock up unused throughput and use them all up. You can stock them up for 5 minutes, essentially bank them, and then use them all up in a sudden burst. That's a temporary thing. With adaptive capacity, it's not temporary, it's just indefinite, it's just always on. It helps you reduce your DynamoDB bill because it enables you to provision more efficiently. Rather than provisioning for a single item that's very high traffic, you can now just provision the table as a whole from what the table as a whole requires. And of course, it's on by default, there's no extra cost. So how does this instantaneous adaptive capacity technology actually work? Well, recall this previous slide here, right? So we've got these tables. They're distributed across several partitions. So if you haven't seen the DynamoDB Under the Hood talk, I strongly encourage you to do so. It's presented by Jasso Sorensen. He's one of our principal engineers. It's a really terrific talk that really kind of gets into the guts of DynamoDB architecture and how DynamoDB works at a pretty fundamental level. I'm not going to recap his presentation here, so I'm just going to do kind of a simplified TLDR of how this works. So imagine the application is driving requests to the AWS network, and those requests are hitting what's called the request router. And the request router is the layer that maps requests to individual partitions, right? So there's thousands and thousands of partitions and physical hosts. The request router is the one that knows where to send each request. And previously, this notion of admission control was made at the partition level. And by admission control, I mean the decision whether to accept the request, to perform the read or the write, or to reject it because there isn't enough throughput. And previously, these decisions were made at the level of the partition itself, right? So the partition looked at its own throughput allocation and said, okay, I'm getting more traffic than I'm allocated to receive, and so therefore I'm going to reject this request, right? And this is, it's not a comprehensive view because each partition only can see what it's, immediately responsible for accommodating. What we've now done this year is we've changed this decision. It's no longer made at the partition level. It's now actually made at the request router level. What the request router can do is it can say, okay, well, this table is provisioned at X, and the traffic coming in is lower than X. And therefore, it doesn't matter what the individual partitions get. I'm just going to let these requests all go through because the customer is provisioned more than the traffic is incoming. And so this is how we've enabled instantaneous adaptive capacity. So just to recap briefly, scalability and performance with DynamoDB, even for imbalanced workloads, right? We partition dynamically for storage and throughput. We automatically isolate frequently accessed items, and we automatically boost if the table is consuming less than it's provisioned at. And again, partitions don't matter, keys do. And if you're concerned about what your individual keys are doing, you can use Cloudwatch Contributor Insights for DynamoDB to monitor those keys. And I forgot to mention earlier that we actually offer 15-day retention for Cloudwatch Contributor Insights data. So we actually restore the data for up to 15 days, and you can scan, you can basically look up traffic trends for data from any one of those 15 days. All right, so another topic that customers frequently ask is, how do I reduce my monthly bill? And let's talk a little bit about provision mode versus on-demand mode. On-demand mode, I won't spend too much time here. We announced this in the last reInvent. It's essentially no capacity planning, provisioning, or reservations. You simply make API calls. You pay only for the reads and writes you perform. And so this eliminates that trade-off I was talking about earlier, right, where you have to balance between over-provisioning or under-provisioning to balance between waste and dissatisfaction. That doesn't exist anymore because with DynamoDB On Demand, you're essentially always 100% utilized, right? You get all the throughput. You don't ask for any throughput at all. DynamoDB just serves your requests as they come in. So a really common question is, okay, well, DynamoDB On Demand has some pretty cool promises about just automatically serving requests with no need to provision capacity. But what are the actual maximum scaling capabilities of on-demand mode? So we actually offer starting throughput. This is for a brand new table that's you just created 10 seconds ago. We offer up to 4,000 write request units, which is sufficient for 4,000 writes per second, and up to 12,000 read request units, which is sufficient for 12,000 strongly consistent reads, or 24,000 eventually consistent reads. Or you can get any linear combination of reads and writes based on these values. And the maximum throughput is effectively unlimited. You could go to millions and millions of requests per second. And it's pay per request. If you use nothing, you pay nothing, right? So if you have a table that's inactive, it's not doing anything, you will pay nothing in terms of throughput. Of course, you would still be charged for any storage of data that's data that's lying on the table. So another interesting concept in DynamoDB on demand mode is this notion of supporting up to twice your previous peak. So let's imagine that this shape here is your DynamoDB request rate. We consider new peaks to be set whenever you arrive at a level that you have not operated at before, and when you actually sustain that level for some period of time. So a brief momentary spike will not set a new peak, but a sustained period will. Behind the scenes, what DynamoDB is doing is it will actually allow you to get maximum throughput up to that red line. And the purpose of this red line and this doubling function is it enables you to essentially double your throughput at any time with no interruption. You can essentially double your request rate. And What's especially interesting about this is that DynamoDB tables do not scale down. So let's say, for example, that you did this pattern, which is on the left-hand side here, this is just a more compressed version of the previous slide. Let's say that this is your traffic. And let's say, for example, that you turn this application off and you just let it lie dormant for a while. The table's still there, but you're not driving any traffic to it. If you come back 6 months later, you can just drive immediately up to that spike with no waiting at all, because DynamoDB tables, on-demand tables, do not scale down. And so a question that customers often ask me is on-demand mode just like a faster version of auto-scaling, where it scales up faster? And the answer is, well, no, absolutely not. Because of this property here. First off, DynamoDB just on-demand mode scales much faster than auto-scaling. And second is that if you were to drive this sort of pattern where you do nothing and then do a sudden spike later, rather than just getting all that traffic throughput accommodated all at once, auto-scaling would essentially dial you up in these sort of stepwise increments. You would have to wait a little while to reach that previous peak you were currently operating at. With on-demand mode, you don't have to wait. You just get all of that at once. So recall that graph that I was showing you earlier, that sort of exponential growth function for the Canadian census. Right? So what I did was I turned this demo off after a couple hours. So you can see on the right here, the traffic drops to 0. And then I waited for about 2.5 hours. And then I drove 30,000 requests per second to this table with no exponential growth function, just immediately drove 30K. And as you can see here, this is the Cloudwatch graph. You get immediately all that traffic all at once. No waiting required, no scale-up required, no throttling involved. So there are some things to keep in mind, though, when using on-demand mode. Initial doubling takes up to 30 minutes. So the very first time you're scaling up to a new level, be sure to allocate your application 30 minutes to double. But this is only for the very first time you scale up. Any subsequent traffic scales instantly to up to twice your previous peak. And of course, on-demand mode is continuously monitored by DynamoDB, so you don't literally actually have to hit 2x your previous peak to get more throughput, right? If you're operating at, for example, 10,000, you don't have to go to 20,000 to get more throughput. You can go to, 11,000 or 12,000, and we will just automatically dial you up behind the scenes to ensure that you have more throughput. And the purpose of this is to gracefully accommodate growth without any throttling that's visible to you. So a common question then is, well, am I better off with provision versus on-demand? And better off can mean, am I financially better off? Is it going to reduce my bill, or is it going to improve my application performance? And the answer is, unfortunately, it depends. It depends on several factors. One thing that you should consider is how much time do you actually spend managing settings? If you happen to spend a lot of time managing settings, well, engineering time, your DevOps time is not free, and that time is probably better spent, building core application logic that's important to your business rather than managing DynamoDB tables. So if you spend a lot of time managing settings, on-demand might be a better choice. How predictable is your workload? If your workload is highly predictable, you might actually be better off with provision mode, because when you can predict how much throughput you need, you can use auto-scaling, or you can just manually provision ahead of your spikes and get high throughput. Because, of course, the per unit price on a per request basis is higher for on-demand than it is for provisioned. Another thing to consider is your utilization ratio. By utilization ratio, I mean the ratio of consumed throughput to provisioned throughput. If your utilization ratio is high, that is, you're consuming most or all of your provisioned throughput, you're going to save money by using provision mode because it's cheaper on a per unit basis. However, if you are consuming at a very low utilization ratio because you've been planning for peak, then it's actually you're going to be saving money when you use on-demand mode. The thing to consider is how mission critical is your application. Some applications are essentially they're not mission critical, or they're actually not throttle sensitive, right? For example, if you have an application that isn't serving customers directly, you can actually be super efficient with your provision throughput and basically set auto scaling to be like 90% of your traffic. This probably means that if there's any kind of burst or jitter at all, you're going to be throttled. But if it's not mission critical, it doesn't matter. You can just save money by using provision mode with auto-scaling. On the other hand, if it is mission critical, you might consider using on-demand mode because it's going to be much more tolerant of throughput spikes, and it's going to minimize any throttling for your customers. Consider also how confident you are in your demand forecast. If you're not confident and you have really no idea how much traffic you're going to get, consider starting off with on-demand mode first. So to summarize, provision mode is best for steady workloads or for gradual ramps that auto-scaling can easily accommodate. If you have events with known traffic, you can even manually provision ahead of time. And provision mode is good when you're willing to invest time in ongoing monitoring to ensure that you're getting the most efficiency, the most bang for your buck on DynamoDB. Use on-demand mode for unpredictable workloads, or workloads that are frequently idle and just tend to spike up out of nowhere. If you have events with unknown traffic, it's really good for those. And it's also ideal for cases when you just don't want to invest time in ongoing monitoring. It's just a sort of set it and forget it mode. Consider your appetite or your tolerance for operational overhead and over-provisioning. Right? You can definitely save money by using provisioning mode. It does involve a little bit more management of the throughput, and you may have to over-provision. So let's look at a couple of real-life examples. So example one is a case where a customer is using pure on-demand mode. So this is actually a real customer. It happens to be one of the business units inside of Amazon.com, the retail business. They support selling on Amazon.com. And as you can see here, their workload is extremely spiky. It happens about once per day on a semi-predictable basis, and they just spike to a really high amount of traffic. The workload has to be processed very, very quickly, but for the rest of the day, they're effectively doing nothing. This is the kind of workload that's very difficult to plan capacity for because you don't really know when it's going to come, and the traffic tends to be very spiky. It's not suitable for auto-scaling. However, it is suitable for on-demand mode. And when they actually switch to on-demand mode here, this is a Cloudwatch graph of their essentially their error messages. You can see that once they switch to on-demand mode in the middle of the graph, all of their errors effectively go to near zero. So that's the first case where you just use on-demand mode exclusively. The second example is when you do a post-launch switchover. So remember what I was saying earlier about you got a big product launch ahead of you and you're not sure how much to provision? Here's an example of that. The yellow line is consumption, and the blue line is provisioned. And anywhere a blue line does not appear, that means the table is using on-demand mode. And what you can see here is that they had a big traffic spike. They weren't really sure how much throughput they actually needed. And once things leveled out, they decided, oh, okay, well, things have leveled out now, and we can just turn on provision mode instead and switch over, and that'll help us save more money. So the third key takeaway is that you should make use of DynamoDB's ability to support different capacity modes to optimize cost and performance. We let you switch once per day, and so you should take advantage of that capability and switch as often as you need to optimize your costs. Right? For example, you can turn on something such as on-demand mode on the weekends, right, when traffic is lower, for example. Lastly, while we're on the topic of of cost optimization, it's worth talking briefly about global tables cost optimization. If you're not familiar, global tables is DynamoDB's essentially built-in multi-region replication capability. It lets you create replicas of a table in any number of regions, and it's a it's a multi-master system. You can do a write in region A, it'll be replicated to region B. You can do a write in region B, it'll be replicated to region A. And just last week, we deployed enhancements to global tables. So what you may have heard already is that you can now have the ability to add regions on the fly, right? So if you have a global table that's in 2 regions, you can now add a third without having to create a table from scratch. You can also now convert a single region table to become global, which was challenging before. In addition, though, what you might not be aware of is we've also improved the replication protocol for global tables. And what this does is it actually reduces the amount of writes that are needed to perform the cross-region propagation. And what this does for you is enables you to save up to 50% on replicated write costs, which are oftentimes the biggest portion of your global tables bill. So if you're using global tables, or you have a workload that would benefit from global tables, for example, if you have a need for disaster recovery, multi-region disaster recovery, or if you have an application that requires essentially deployment across multiple regions for maximum low latency and data locality to serve your customers in Virginia and Europe and Tokyo with the nearest possible region, considering using the latest version of global tables. So to briefly wrap up, we talked a little about some of these principles. DynamoDB accommodates your workload, not vice versa. I hope you all can walk away here, not focus on partitions anymore. Just think about your individual keys. Try out contributor insights for DynamoDB to actually see what's going on with those keys. Make sure to switch capacity modes, whenever you need to. And be sure to be aware of the more flexible, more cost-efficient global tables. Now, I didn't talk about everything that's new in DynamoDB. We actually shipped a lot of stuff this year. So this is a list of all of the notable launches that we've had in 2019. Something that I didn't talk about, but is actually pretty interesting, is the NoSQL Workbench for DynamoDB, which is essentially client-side software that you can use to model data models on DynamoDB, try different key schema designs. And it really accelerates your transition from, say, modeling on a relational workload, a relational database, into a non-relational database. And the techniques and principles that you'll learn from the NoSQL Workbench are applicable not just to DynamoDB, but actually to several NoSQL databases. Related sessions, I strongly encourage you to check out Amazon DynamoDB, the data modeling with DynamoDB. Data modeling is super important in DynamoDB to get maximum performance, to get maximum cost efficiency. It's really going to help you out to learn how to model optimally with DynamoDB. And I encourage you also to watch the Under the Hood session to learn how DynamoDB works behind the scenes. You can also go to several sessions made by our customers, Uber, Verizon, and Intuit. And lastly, you're all here at reInvent to learn. Wanted to talk briefly about the new training and certification for several databases, not just DynamoDB. It covers Aurora, Neptune, that whole list. And you can validate your expertise with new specialty exams. So that concludes the presentation. Thank you very much. And please remember to complete the session survey in the mobile app. At this point, I'll take questions. If you have questions, please come to the podium there.